Good day everyone, we are the group 1 from 223 and the issue that we chose is about climate change. Especially now that we've been experiencing here in the Philippines a tremendous weather patterns that we've been experiencing over the past few years. And we can see that chemistry has a great influence on how we perceive and how we deal with this kind of issues. So for example, one of the reasons or causes of why climate change is happening is due to the um, greater amount of the greenhouse gas emission. Now, greenhouse gas emissions such as carbon dioxide, nitrous oxide, or methane are the primary or major greenhouse gases. Greenhouse gases traps the heat coming from the sun, but the energy coming from the sun that warms the earth is supposed to reflect back into the atmosphere. But due to the greater amount of the presence in greenhouse gases, it traps the heat coming from the sun, and which makes the surface of the earth, may it be water parts or land body parts of the earth, it increases the temperature among those parts, which in effect changes the patterns or weather patterns or the seasons in different parts of the world. Here in the Philippines, there's a study held by the professors in UP Diliman. They've created a simulation on how will the future typhoons be stronger in terms of its strength and effect here in the Philippines. For example, the CDP from a future cyclone similar to Super Typhoon Yolanda was seen to be as much as 37% greater than the damage experienced in 2013 brought by Typhoon Yolanda. And now, currently, we've been experiencing different type of heat daily. That's why some classes have been suspending due to the amount of heat or the temperature level here in the Philippines.
Hi everyone, let's talk about how chemistry explains climate change. Climate change is a basic chemistry concept, also known as the greenhouse effect. Certain gases like carbon dioxide, methane, and water vapor traps heat in the Earth's atmosphere. These are called greenhouse gases. They let sunlight in but they absorb and re-radiate heat, keeping the planet warm, kind of like a chemical blanket. Carbon is a major player, where we burn fossil fuels like coal, oil, or gas, we're releasing carbon dioxide. That's combustion, a chemical reaction where carbon in the fuel reacts with the oxygen to form carbon dioxide and water. Here where it adds up. More combustion means more carbon dioxide in the atmosphere. That extra carbon dioxide traps more heat, which leads to rising global temperatures. That's global warming, and it's driven by human activity. And it doesn't stop there. Carbon dioxide dissolves in oceans too, forming carbonic acid. That lowers the pH of seawater. This is called ocean acidification, and it's harmful to marine life, especially organisms that rely on calcium carbonate for their shells. So yeah, climate change is deeply connected to chemistry. Understanding the reactions, the gases, and the changes helps us to make better choices for the planet.
So, knowing the process and the effects of climate change, what can we do? Well, inorganic chemistry provides elegant solutions to capture and permanently store these greenhouse gases. For instance, try to imagine a tiny, intricate cage built from inorganic materials such as metal organic frameworks, or MOFs. These act as molecular sponges, selectively trapping CO2 from a power plant emission or even directly from the air, a process known as carbon capture storage. Another way is to look outside because nature itself provides inspiration. Mineral carbonation mimics Earth's natural weathering process, so reacting CO2 with silicate-rich rocks, form stable solid carbonate minerals. This in turn locks away the carbon, turning a harmful gas into a harmless stone. Furthermore, inorganic semiconductors like titanium dioxide can act as photocatalysts, harnessing the power of sunlight. These minerals can drive chemical reactions that break down harmful pollutants and even convert captured CO2 into valuable fuels. So, from molecular traps to artificial photosynthesis, inorganic chemistry offers powerful tools in our fight against climate change. By understanding and harnessing the fundamental properties of inorganic matter, and in turn, we can pave the way towards a more sustainable future.
So as we face the realities of climate change, one thing is clear. Every choice we make matters. From rising global temperatures to extreme weather events, the science is telling us we must act, and we must act now. But here's the good news. Chemistry is on our side. Chemistry plays a powerful role in understanding and combating climate change. It helps us analyze greenhouse gas emissions, develop cleaner energy sources, and create sustainable materials that reduce our environmental footprint. From biodegradable plastics to carbon capture technologies, chemistry offers innovative solutions that can reshape our future. The fight against climate change isn't just for scientists or world leaders. It starts with us. Learning more about the science, supporting initiatives that push for cleaner alternatives, and making small but meaningful changes in our everyday lives. Whether it's reducing waste, conserving energy, or choosing eco-friendly products, our actions count. So let's stay curious, let's stay committed, and let's use the power of science, especially chemistry, not just to understand our planet, but to protect it. Again, this is the Group 1 of BSCIEPHY II-23. Thank you for listening.